Welcome to this explainer. Okay, today we are tackling a massive, fundamental shift in the world of cybersecurity. For decades, we really just relied on a single line of defense to protect our computers. But, as you probably know, the threat landscape has changed drastically. So we're going to explore exactly why traditional antivirus is simply no longer enough to keep an organization safe, and why a technology called EDR, Endpoint Detection and Response, has rapidly become the modern, absolute, mandatory standard. If you want to understand how modern networks actually defend against sophisticated attacks today, you are right where you need to be.
Let's dive right into this by anchoring our understanding with a super simple analogy. Think of traditional antivirus like a security guard standing right at the front door of your building. That guard has a clipboard with a list of known bad guys. If someone on the list tries to get in, boom, the guard stops them. But if a brand new, unknown thief walks up wearing a nice suit, the guard just waves them right on through. EDR, on the other hand, is like having a state-of-the-art CCTV network installed throughout the entire building, constantly monitored by a dedicated security team. It's watching every single movement inside. Even if someone sneaks past the front door, the team is absolutely going to notice if they start prying open locked file cabinets or crawling through the air vents, and they'll step in immediately to stop the attack.
Here's exactly how we're going to break this down today. First, traditional antivirus. Second, we'll enter endpoint detection and response. Third, a real-world PowerShell showdown. Fourth, a head-to-head comparison. And finally, building the modern enterprise stack. All right, Section 1. Let's quickly establish our baseline by defining what traditional antivirus actually does.
For years, AV was the primary, and honestly often the only, defense on an endpoint. Its main goal is pretty straightforward: detect known malware, block malicious files, and prevent a virus infection before it takes root. It does this mostly by using signature-based detection. Basically, it compares files against a massive database of known bad malware hashes. Think of these as digital fingerprints for viruses. It also uses some basic heuristics to spot obvious bad patterns and checks cloud reputations in real time, right as you try to open a file.
Now, this perfectly illustrates the linear logic of AV. It acts as a strict, localized checkpoint. Step 1, a file tries to execute. Step 2, the AV engine jumps in and scans that file against its signature database. Step 3 is just a simple binary decision. If it matches a known bad signature, it gets blocked and quarantined. But if it doesn't match, it's allowed to run. It's a very black and white approach to security.
And that right there is the crucial point. That exact linear logic creates a massive blind spot. Because it relies so heavily on checking files against a list of known threats, an attacker using completely new unknown malware, what we call a zero-day, can bypass it without breaking a sweat. Even worse, modern attackers often use fileless attacks or heavily obfuscated scripts that execute directly in the system's memory. Because there's no actual file dropped onto the hard drive for the AV to scan, the attacker literally walks right past that security guard at the door without even being asked for ID.
Which brings us to the paradigm shift. Section 2. Enter Endpoint Detection and Response.
Endpoint detection and response was specifically designed to catch the exact things traditional AV misses. Instead of just looking at static files at the single moment they execute, EDR continuously monitors the endpoints. It's watching the actual behavior of the system to detect suspicious activity. It gives you tools to investigate attacks deeply, and crucially, it can respond automatically. This means it's actively hunting for those unknown malware strains, fileless attacks, lateral movement, or advanced persistent threats that are just quietly living off the land, using legitimate system tools for malicious purposes.
Look at how different this operational flow is compared to the linear AV checkpoint. With EDR, it's a continuous loop. First, a lightweight agent collects massive amounts of system telemetry. It's basically a continuous log of every single thing happening on the computer. Then, a behavior engine, which is often powered by AI these days, analyzes that data looking for attacker techniques, rather than specific files. If it spots a red flag, it generates an alert. And finally, it triggers an automated response. That can mean instantly killing a malicious process, or even completely isolating that computer from the network so the infection literally cannot spread.
Now, what makes EDR a real game changer is the sheer depth of visibility it provides. It's not just looking at your downloads folder. It monitors running processes like PowerShell or the command prompt. It watches the system registry for attackers trying to establish persistence. It monitors network traffic for communication back to malicious command and control servers. And it even scans the system memory to catch that tricky, in-memory, fileless malware. It is comprehensive, whole system surveillance.
Let's move to Section 3 and see how this actually plays out in a real-world showdown using a malicious PowerShell attack. Okay, imagine an attacker tricks a user into triggering a malicious PowerShell script. With traditional antivirus, PowerShell.exe runs. But because PowerShell is a trusted, built-in Windows tool, the AV doesn't see a bad file. There's no known malware signature to match. Within seconds, the attack completely bypasses the AV defenses, and the attacker has a foothold in the system. The guard at the door essentially saw an employee badge and just waved the attacker right through.
But put that exact same attack under EDR's CCTV, and the story changes completely. EDR sees Microsoft Word suddenly launching PowerShell. It notes the PowerShell then attempts to connect to the internet to download an unknown payload. EDR's behavioral engine instantly flags this sequence of events as highly abnormal, because let's be real, a word processor has absolutely no business downloading executable code from the internet. Within seconds, it triggers an alert, kills the process, and automatically isolates the machine from the network. The behavior was caught red-handed, even though the tools used were totally legitimate.
All right, Section 4. Let's put these two approaches head-to-head across an entire attack chain to really cement why this evolution is so critical.
Look at this matrix. Sure, both AV and EDR can catch initial known malware, but what happens after the attacker gets in? AV is completely blind to lateral movement. That's an attacker hopping from one computer to another. It completely misses data exfiltration, where an attacker is stealing your private files. EDR, however, maintains strong visibility and defense across every single stage of the attack, right down to catching and often rolling back ransomware encryption.
To summarize the technical shift, we're moving away from a reactive, file-focused baseline that relies on static signatures to a proactive, behavior-focused security operation. AV simply tries to prevent a file from running. EDR assumes attackers might eventually find a way in, and instead focuses on detecting their behavior and giving you the tools to aggressively respond.
And if you're looking at this from the perspective of a Security Operations Center, or SOC, the difference is night and day. For a security analyst, traditional AV is really just a prevention baseline. It offers very low visibility into what's actually happening on the network. Conversely, EDR serves as a comprehensive operational platform. It's an investigation tool that lets analysts see exactly what happened, step by step, and it serves as a proactive threat hunting platform to actively search the shadows for hidden attackers before they strike.
Which brings us to our final part, Section 5. What should you take away from this when designing your own modern enterprise stack?
For any serious enterprise environment, and especially if you're in a highly targeted sector like banking where you're protecting ATM systems, SWIFT networks, or domain controllers, the recommendation is crystal clear. Relying on traditional AV alone is incredibly dangerous. It is definitively not enough. EDR, or its broader cousin XDR, should be considered absolutely mandatory. Furthermore, deploying EDR alongside multi-factor authentication and feeding all that data into Essential SIEM, which acts as the main security brain for your IT team, provides the layered, robust protection you actually need to survive modern threats.
Which leads us with this final critical thought to evaluate your own security posture. If a sophisticated attacker walked quietly past your antivirus guard at the front door today, say using stolen credentials or a fileless script, do you have the EDR CCTV in place to catch their behavior before it's too late? It's a question every single organization needs to answer. Thanks for joining me for this explainer. Keep learning and stay secure.